All right, good morning, everyone. Today we're going to be talking about abstraction and encapsulation. We're mainly going to be focusing in the concept of instance versus class attributes and methods. Yesterday, everything that we programmed or everything that we made was within the spectrum of an instance. Today we're going to talk about the difference between the instance and the class, both in methods and attributes. In part one, we'll talk about instance versus class attributes. We'll then create a new task class just to get a little bit more rehearsal. And then we'll define access between instance and class attributes. Now, in part two, we'll talk about instance methods and class methods. We'll dive over the difference between the keywords of CLS, which stands for class and self. And we'll actually go over the data flow first, over how everything is being created and data is being managed between the class and the instance. And we'll leave static methods for the very end. Now, static methods can become a little confusing, so that's the reason why we're moving it to the very end. All right. Does anyone have any questions over what we'll be covering today? Fantastic. Let's go ahead and dive straight into our PowerPoint in that case. So today we're covering intermediate OOP, instance versus class attributes, instance versus class methods, and just a friendly reminder, all of this material you will be tested upon will be on assessment 1, which is happening at the end of this week. All right, so classes versus instance. When you think about the hierarchy of OOP, think of an organization, which is a class, that has many departments within it. These are all the instances. Now, this could be a little bit confusing. What we're essentially saying is that a class holds an instance within it. And it's good to think about it this way, because then anything that needs to be global to all instances can be set at the class level, right? It's just a hierarchy when it comes to data, meaning that, let me see if I have a nice handy dandy arrow. I do. Data can go from can go from classes, messing up my arrow there, from instances up to the class, meaning that an instance can grab all information from a class up above it, right? So for example, you're inside of a building, you're working in these many departments. Well, you go to the building management office to be able to grab anything that applies to all of the separate rooms within said building. All right, this may be a little bit more clarified once we start seeing it in code. We can start thinking about class attributes and methods that can be accessed by all instances of the class, and then instance attributes and methods that can only be accessed by said instance, and changing these attributes would only reflect on one instance. So if we're comparing it to a building, let's say the building manager decides every single building must have this type of fire alarm, or excuse me, every single room must have this type of fire alarm. Well, that's global, right? Meaning that it's common across all rooms. And if it needs to change, the only person that needs to be tracking that the fire alarm is changing is the building manager. The building manager can change that, and then he'll take care of going through every single building and changing that information for them, right? Now, in each one of those rooms, there could be a separate business running. As you can see here, we have a finance building. We have one that's, we have a finance room, one where there's a receptionist. There's a couple statistical data being ran. The information is unique to each one of those rooms. The situation that is being handled is unique to each one of those rooms. And each one of those rooms, although they may share the same method, for example, presentation might be the same method that happens within each one of those rooms, it is delivered in a different way, unique to its own independent needs. All right. All right. At this point, does anyone have any questions over that example? Okay, doesn't seem like we don't have any questions. So let's actually write some code to take a look at this information. So I'm going to bring us back to our doc class from yesterday. and do a real quick dive into some things that we can apply here. So for example, we have our dog here, which is Shadow. We know that it's supposed to be a German Shepherd. And there's a couple of things that we can make global to German Shepherds, right? For example, our dog pound, if we pull up our dog right now, it's not very descriptive. All it tells us is that we're working with a dog. We can definitely change the name of the class. All right, we can come into this class and instead of calling it dog, we can name it German Shepherd. So now we have a German Shepherd dog. And a name would be unique to every instance. The height would be unique to every single German Shepherd that we have. Weight, lifespan, not so unique, right? When we're talking about lifespan, that's probably something that's an average for all German Shepherds. So actually, I'll leave it there, but we will make a note that it is not unique to each instance. Now, how long they actually live will be unique to each instance, but their average lifespan would not, right? And then we have the color and temperament, all of which would be unique. Well, since we know lifespan will be something that is the same across all instances, no matter how many dogs I can make Shadow, I can make Sally, I can make Apollo, Zeus, Tank, whatever kind of dog it is that I make, the expected lifespan will remain the same for every single one of them just because they are a German Shepherd dog. Well, because of that, that would turn that attribute into a class-based attribute. Now, class-based attributes do not utilize self. So just go ahead and escape that. Let me put this visual, this nice handy dandy pilot to sleep so it doesn't get in the way. So class level attributes do not utilize self. And I guess we could make it this way. So class level attributes do not utilize self. They are globally accessible across all instances. And we'll stop there for now. So now we could add lifespan is equal to, and here we can just pass in the hard-coded value of what we expect our lifespan to be. So in this case, our lifespan should be somewhere around 13 years. And I can actually comment this out and change my initializer to no longer take in lifespan. Now, some other things that are common across all dogs or all German Shepherd dogs that I'll have. Well, I can specify their breed. All of them will be of German Shepherd. I can specify legs. Right. Ideally, they will all have 4 legs, not 3 legs. I apologize. Of course, we do have the special case where some of them may be injured and they have 3 legs, but for the simplicity of this example, we'll keep it at 4 legs. Right, we could say they all have tails, they all have ears, etc. But all of those attributes, which are describing our dog of a German Shepherd that are common across all of them, would fall under a class level attribute. Notice how class level attributes come in before the init method. Well, that's great in practice. What would that look like when I'm actually running some code? And let me make sure it's the right main. It is. I can say from dogs, I want to import the German Shepherd dog class. And here I can go and create a dog. So I can say, my dog, let's make this easier. Let's do Apollo is equal to a German Shepherd dog instance. We can see that it takes in a name. In this case, the name will be Apollo. It takes in a height. Let's do the height at 35 inches. The weight at 115 pounds. Color being brown. I think this one is expected in lowercase letters. And then temperament, I'll just go ahead and say the dog. And now if I go to print out Apollo, you can see that we get Apollo is a dog that weighs, not weights, interesting, 125 pounds with a temperament of good dog. Nice. So I was able to create my dog class without having to pass in what kind of breed it is or what their life span will be. But notice that if I type in lifespan here and I execute this code, I still receive the lifespan attribute. It's coming in from the instance of a dog. So currently, Apollo is an instance of a dog, and I am currently capable of accessing. Oh, it's not very mixed as an image. I'm currently capable of accessing the attribute of lifespan, even though it belongs to the class. Well, if we come down to the scoping here, you can see that the instance can access the class level attributes. Okay, well, let's see what happens when I do this number. I'm going to go to German Shepherd Dog. If I print German Shepherd Dog, you can see that all I get is a location. It says in the file of dogs, you have a class declaration named German Shepherd Dog. But what if I add in the attribute of lifespan? And I execute this information. Well, I'm still able to see lifespan. Right? In that second example in line 5, I am accessing my class declaration and still able to see lifespan. So the class can access the class level attributes, and the instance can access the class level attributes. Well, what about something like name? Let's see that example. Give me a second, Alex. I'll get to it right now. All right. If I execute this code, in the first example in line 7, I'm seeing Apollo actually gets printed out. But if I come down to this print German Shepherd Dog on line 8, it's telling me this is a property object, but it doesn't actually show me a value. Well, that is because this here is an instance attribute that holds no value until an instance is created. Right, so Apollo works perfectly fine because we actually created an instance for Apollo. That's the reason why we're able to see that name being printed. But if I try to print it down below through the actual class, it doesn't work because the class can't access the instance specific data. Only the instance can access the class. And that's why up above, we can see that German Shepherd Dog at lifespan prints correctly. All right, let's go ahead and open it up for questions. Go ahead, Alex.
Real quick, you just said it's best practice to code all class level attributes before any methods, including the initiate method.
That's right. Yeah, so class level attributes are typically stated right under the class declaration. So if you, in this case, I declare my class on line 8, and the next 3 lines would be my class level attributes.
Got it.
All right, Sam?
Yeah, would it be wrong to call a class level attribute a class variable?
No, it wouldn't be wrong if you're trying to simplify it for yourself. But I would like to emphasize that the vocabulary is going to be important, specifically since the end goal here is, of course, for all of us to get a job inside of software engineering afterwards. Referencing to things as variables when they're class attributes might be a little bit of a, okay, maybe this person doesn't feel too comfortable in OOP or hasn't messed around in OOP enough to know the correct vocabulary, right? So that's like a flag that you want to avoid. Does that answer your question, Sam? Of
Yes, it does. Thank you.
course. All right, Rick.
Okay. Yes, is this kind of what I may have accidentally done yesterday with the guessing game? So with the guessing game, the self attributes, instead of, I mean, I guess I could have done it like you did up here before you do the init. But I did it inside of the init where I was like, I don't want to um, have to code what the answer, self dot answer is. I'll just make it equal to the um, random, random dot randomit, uh, uh, 0 to 100. Is that kind of what I did yesterday when I did that?
Yes, from the sounds of it, you ended up making a class level inst or a class level attribute, but you just set it to the return of a random function.
Okay, so I kind of did that yesterday without realizing. All right.
All right, awesome. Okay, so it seems like this concept of division of labor is pretty common to everybody, or at least easily readable to everyone. So let's go ahead and move into a separate example here. Let's say I want to map out a task. I want to walk us through being able to create some sort of task manager application where we're going to have a class of tasks. So let's work here. Here I have my class declaration, and let me just change a couple of syntactical stuff there. And at my class declaration, I have my task. I know every instance of a class should have a title that should be unique. I know every instance of a class should also have a fact whether it's completed or not. And this should also be unique. Now, things to start considering here is, well, for example, my title, what kind of data type do I want this to be? In this case, I would like it to be string. And then for completed, I think a Boolean variable should do the trick there. All right, so there I have discussed what my instance attributes should be. Now, let's say I want to work within a task. Every time a task is generated, I would like it to also have an ID to kind of resemble what an application would actually look like. And this ID should be unique. Now, in order to make sure that this ID is unique, there needs to be some sort of tracker in a global scope that keeps track of the last ID that was utilized. So I could always use a set here. So I can make this used. Let's do class level attributes. And here, I know that I'm going to need past IDs, which would be a set. And this would be global to all of them, so that every time I create a new instance, I can take that into consideration. All right, and then preferably, if there's going to be different users, I may have an owner. right? Which may also be another class object. And this should also be global to all of the instances of the, or to all of the tasks that are being created. Okay, so there I have some past IDs, some owners, and maybe I even want to do something like a database that keeps track of everything. But this is more of a specific example here of how a class might be rendered. Okay, so again, I have a task, which has some class level attributes, such as past IDs, which will set to a set. We have an owner, which may be a class. I don't think we have enough time to generate another class, so more than likely I'll just put a string there to represent the owner. And then we have our instance attributes, which in this case we have an ID, the title, and whether it's completed or not. Right. Another common practice to do here is, for example, if you have completed, you may pass in something like default completed value, and that might be something that's globally to everybody instead of just dictating it inside of the initializer. Because if you dictate it inside of the initializer, you can't change it later on, right? Whereas if you dictate it inside the class, you can always change it dynamically through the program. Okay, so there's my map for what the class of task should look like. Does anyone have any questions about how I ended up mapping this task? Why is it that I think this information should fall where it falls? And why are class level attributes located where they're at instead of instance level attributes? Let's hear it, Alex.
So the ID for the initiate method. How, I thought you said that class level attributes can't access instance level data.
That's right. So class level attributes would not access the instance. Instead, what we're going to do is when an instance is created, we'll access the class level attribute, right? And then we'll update the class independently.
Okay.
All right, Tom?
I guess it goes into like, how would you necessarily determine what needs to be global specific versus instance specific? Like, is it one of those things to where most instances, like majority rules kind of thing, or if more than one instance needs it, make it global kind of rule?
Yeah, that's a great question. And when it comes to it, I think I would say use the majority rule and then consider edge cases later on. And if you ever find yourself manually writing the same thing, let's say more than a few couple of times, like you're writing it enough to where it raises a flag in your head of, hey, I'm rewriting this information over and over again, more than likely needs to be a class level attribute. That way it's just in there once and it's shared globally. Does that answer your question, Tom? All right, great. Rick?
Yeah, I think it's actually starting to fall into place. So, like, I give the same example, the guessing game. All those attributes were instance attributes, and if you were doing something inside the instance, then any calculations or functions that you were writing had to be inside the class, or else you couldn't use it. But if you have a class attribute, those can be used outside of the class. Is that what you're saying?
A class attribute can be utilized within outside of the instance of the class. Yes, if that's what you're referencing.
Okay, so outside of the instance, not outside of the class.
Right.
Okay, but you can still, like, if you go to a separate file, you can call the class and create an instance of that class in your other file.
That's right. Yes.
All right, I think it's starting to fall into place. All right, thanks.
Okay, awesome. Well, now that we have this map here, let's go ahead and start drawing it out. All right, we drew it out. I have a nice mental picture of what I want it to look like, but now there's a specific data flow that I want to follow, right? Gonna go ahead and open up this task tracker. Gonna open up tasks and their main.py accordingly. And here you can see that I have the class of tasks. Now, preferably you want this pluralized whenever you go naming your classes, because there's going to be many of that one. So here we go. We're dealing with a task here. And what we're actually, excuse me, I have to redefine that if we want to pluralize or not. But now we can go ahead and start writing out our code. And we're at the point now where we've seen enough Python to level up our Python, basically to the next iteration of what's expected when it comes to programming. So the syntax that I'll be utilizing today will utilize a bit of typecasting. It's not going to be enforced by the language whatsoever, but it's mainly for developers to look at and be able to understand your code a little better. So as I'm writing the code, if at any point anyone has any questions, please raise your hand, and then I'll make sure to clarify the syntax afterwards. Okay, so here we have our class of tasks. Our class of tasks has something called past IDs, which will be a set. And I'm going to make it equal to a set. All right, so this colon is defining that past IDs is a variable that holds a set. All right, now my owner, in this case, will be a string, and we'll go ahead and set it to myself, which is Francisco. And finally, we have our default complete, which will be Boolean. And we're going to set this to false. By default, all tasks that are created will be false. Now I can go to my instance. So I can say instance, or excuse me, my init method, which takes in self. It will take in title and completed. And if completed is not available, I can always utilize my tasks dot default completed. And it doesn't seem to allow me to do that there, so I'll be doing it later on. Here we have a Boolean, and here we have a string. Now, this method is not going to return anything. So I can just say none. And actually, it does return something. It would return the instance of the class itself. We'll leave it as none for now. All right, fantastic. Now, I can say self.title, which we know is a string, and set it to the title that's being passed in. I can say self.completed is equal to completed. And I can run a little bit of an if statement here. So I can say that the other thing that can be passed in will be none. I can say if completed, else what I'm going to set it to will be self.default completed. Okay, so a little bit of text that has just changed now. Again, my title, which is a string, I have completed, which would either be Boolean or none. If no completed value is being passed in, we'll set it to the default complete of the class, which in this case will be false. If it is being passed in, we'll set it then. All right. Does anyone have any questions over how we went ahead and created our task class with some class level attributes and some instance level attributes? And it seems like I'm missing ID still. So let me go ahead and add that really quick. So self.id is equal to And we'll do this ID here shortly. All right, Tom.
Yeah, so the colon and the data type there, is that actually type casting it, or is that just saying this is the type it should be as kind of like a reminder?
It's more saying this is the type it should be as a reminder for other developers so that they can read your code.
Okay.
All right. Any other questions? Let's hear it, Alex.
Yeah, to piggyback off of Tom's question, I thought typecasting was sort of like to the right of past IDs, to the right of the equal operator. Um, I think that's how I think typecasting is done, and then you would put whatever you want as a set within the parentheses, right?
That's a great question. So this set is actually going to create the data structure. I'm not sure if we've seen a set being utilized before, but creates the data structure of a set. What is telling me that past IDs is a type. So for example, if I hover over past IDs now, you'll see that it tells me that it's a set. Same thing with an owner. It will tell me, hey, this is, tell me literal, which is a string. And if I go over default comp, tells me that it's a literal, which is a false, right? But as I'm referencing all of these down below, you can see that it's telling me, giving me a hint as to what value is supposed to go in there and be held within the actual variable. In typecasting language or type-oriented languages, there will be an actual reinforcement, meaning that you can't pass in the wrong types into specific variables. But with Python, it actually accepts it. It doesn't reinforce the casting of types, but it does make your code a lot more readable and give you a lot of good hints later on when you're working inside of methods. So for example, if I want to utilize some sort of string method later on the title, let's say I do something like title.split. Well, now it's able to identify that title has a method named split. And it's only able to identify that because I'm passing in the string method. Because if title was any, and I try to pass that in, you can see that it's not able to identify the function because it could be any type of parameter. Does that answer your question, Alex?
It does. Thank you.
Of course. All right. Well, now we went into creating this class here. Our class has some past IDs, our default owner, we have our initializer, but we know that we need to reinforce some getters and setters as well. Well, I'm going to do my app property value here. I'm going to access title, which will be self. And it'll return self.title. Now, self.title doesn't necessarily exist yet. That's because I haven't created it. So I'll say, or excuse me, underscore title. So I'll call my setter self with a new title. Oh, that is the wrong. Boom, there we go. And I just want it to be in title letters. So I'll say if new title not equal to, you know what, we'll just make it this way. Let's say self.underscore title is equal to new title title. And I'll make sure that this is identified as a string method. This method will return nothing. And this method is going to return a string. Okay, so now I have my getter and setter for a title that can be generated. I can pass in whatever, it could all be lowercase letters, and I'll actually save it as a inside of title format. I can grab that title as well. Completed doesn't necessarily need a getter and a setter just because it's already a Boolean variable, but I guess I would want to reinforce that it is a Boolean. So let's go ahead and add that there. Let's do completed, which takes in self and returns self._completed. And then we can dive into completed.setter, which takes in self, a new value, which should be a Boolean. And give me a second here. This would turn a Boolean here. And I did this wrong yet again. I apologize, everyone. All right, there you go. Now let me pause here for a second. Go ahead, Tom.
Yeah, your Boolean example actually made me remember a question I forgot, and that was with this getter and setter process that you showed us, are you able to have just a getter or just a setter? Because it seems like they're kind of codependent on each other with how it looked like it was structured.
You can have just a getter without a setter, but you can't have a setter without a getter. Does that answer your question? I see head nods.
Yeah.
Okay, perfect. All right, let me go ahead and continue pushing here. So we have our completed here. And actually, this might be a good idea to check on both of them. Let's make sure that if type of new title is equal to string, then we do the following. Else, we want to raise an exception saying title should only be set to a string. So if type of completed, or excuse me, of new value is equal to a Boolean, then we could say self dot completed is equal to the new value. And then else we can raise an exception stating completed should be set to a Boolean. All right. So there's a couple of getters and setters there for being able to manage all this information. The final part's going to be our ID. Well, here we can create a ID getter. So we can say df ID, or let's do task ID so that we don't occupy the ID keyword. Pass in self. And all this is going to do is return self.task ID. So we need to specify that this will return an integer and that this is in fact a property. Now let's do a setter here. And this is a perfect example of something that would have a getter, but not a setter, right? Let's do task ID here. And actually, I am going to have a setter here, which will be new ID. We know that this is going to be an integer. I can say task ID dot setter. I'm doing a lot of coding here. I apologize, everyone. I know I have been kind of speeding through these getters and setters. I want to make sure that we get going for the class versus instance informations. So here we have our task ID. I'm going to say if has attribute, pass in self, and then pass in task ID. Then I want to raise an exception saying ID has already been set. If the new ID is not an integer type, then I want to raise an exception stating ID must be an integer. And then finally, I can say self dot task ID is equal to the new ID. All right, so there's a lot of getters and setters there, but now we need some sort of method to actually be able to generate an ID. So here we can say, all right, I want to generate an ID here, and we have that pass set available for us. So I can say task create ID. This could accept self. And all I really need to do is return an integer. So I'm going to say if self dot past IDs. So if there are any values inside there. So let's just do len, right? If it's not 0, then what I'm going to do is I'm going to return the max of the list of self.past IDs. And then otherwise, or excuse me, let me do this number. Let's do new ID is equal to so-and-so. Otherwise, new ID is equal to 1. I need to make sure I add 1 here because we're always going to be incrementing. And then finally, I can say self.past IDs. I can add the new ID and then return the new ID. Well, now that this method is created, up above, I can say self.taskID, which I know is of an integer type. And here I know this is of a Boolean type, is going to be equal to self.createID. And if I hover over this self.createID, we can see that it's going to return an integer. All right, that was a lot of coding. Again, we have our class level attributes. We have our instance level attributes. This is just a quick refresher over getters and setters. This isn't the topic that we're going to be covering today. We're able to create a method that will generate a brand new ID. And notice that in this method, when I call self, I'm still able to grab those past IDs, right? Because again, I have access from the instance to the class. So I can say self and still grab those past IDs to generate a brand new ID for me. All right, fantastic. At this point, does anyone have any questions over anything that we've coded up to this point? I see a couple. Go ahead, Rick.
Yes, this is more of a, I guess, a VS Code question. So following you in the coding, as soon as I saved it, I guess it's not enabled in VS Code. I'm not sure how to enable it. The typecasting. It says, typecast checking is not enabled. Do you know what I'm talking about?
I do, but I would have to take a look at your environment. So after class, I'll go ahead and meet up with you, and then we can go ahead and dissect that to make sure that it works properly. Awesome. Tony?
Yeah, I grasp most of the concepts. The only thing I really am curious about, because I'm not very good with these strings, is can you go over what all of that means?
Let me see. Okay, so this portion here.
Yeah.
Awesome. So this here is going to be the equivalent of saying, let me go ahead and point it out this way. If I were to write my init method, this would be self, title, completed, where completed is default of none. All right. Now, what this is saying down below is it's saying title will be a string type. So let me go ahead and do this.
Yeah, I'm more focused on the completed portion of it with all of the or statements and stuff. So is that basically just saying that if a Boolean isn't provided there, it's automatically going to default to none? But in the instance, if you put the Boolean there, it's going to go to the Boolean. Is that basically what that's stating? Okay.
Yes,
It's just
that's
it's a lot, and I've never seen it written like that, so I wanted to make sure I was tracking that.
okay, perfect. Yeah, so this is just saying it's either going to be Boolean or none, and then the default value is none.
Got it. Okay, thank you.
Of course. All right. Any other questions? All right, so if there are no other questions, let's actually take a look at what we have here. So we have our tasks. I'm going to go ahead and import from the task tracker dot tasks. I'm going to import, and actually let me take off this task tracker portion because we're not in a module. I'm going to import tasks, and I'm going to create a couple of them. So I'm going to say task 1 is equal to a tasks. We know that it's going to expect a title. And now notice how when I open this constructor, it's also telling me the types that I'm looking for. It's not just giving me the option of providing any. I can still provide any, and there would be no reinforcement through Python, but it's at least giving me a hint of, hey, this is what this is going to do. And it tells me what my return value will be as well. So in this case, I'm going to say, go some more. Now I'm not going to pass in anything. I'm going to, for task 2, going to have code some less. And then finally, for task 3, I'll have get some sleep. Okay, so there's my 3 tasks. A couple of things that I want to print out. So I want to print out task 1. Actually, I'm going to go into my task and just provide myself a dunder method. So here's my dunder string. And what this is going to do is it's simply going to provide a string method of where I'll specify the task title. I can grab the ID as well. And then finally, I can grab if it's completed. All of which I'm using my getters and setters for. Well, now let's just print them. All right, let's do a little bit of list comprehension here. Let's print task for task in task 1, task 2, and task 3. So now if I execute my code in main.py, excuse me, I'm inside the wrong directory there. I see there's an error being risen here, so title should only be a string. That is what I'm passing in is a string, so I'm wondering what's going on here. It looks like that problem's coming in from my setter here where I'm passing in new title. An exception is being risen. So let me go ahead and print new title. And then I'm also going to print type of new title to make sure that I did that properly. Okay, let me come up here. Okay, so I'm getting class of string. So maybe the issue is that I passed in the quotation marks. Let me make sure that works. Yeah, so that's what it is. Just the fact that I passed in some quotation marks. So let me take that off really quickly. Oh, task integer. All right. And there you go. We can see that I'm able to create all of my classes. I forgot to take off that print statement. And for every single one of my classes, my IDs are increasing. If at the very end, I decide to print those IDs, I can print them from the tasks. And here I can say, hey, tasks, past IDs. If I run this, you can see that past IDs have incremented by 1, 2, and 3. And let's say at some point I decided that the default value should be true. Say throughout my program, I say, you know what, I want to change the default value of what tasks are. Well, now I can change it to true. And if I float over it, it tells me, hey, this is supposed to be a Boolean, so you might want to change that. And when I execute my code, you can see that now only one of them is false, which is code sum less. That is at integer 1. You can see that the other two tasks, which are being created after that change on line 4, have it as true. All right, so there's our class versus instance level attributes being activated. All right, does anyone have any questions over class versus instance level attributes? Okay, if no one has any questions, let's go ahead and stop our recording here.